Have you ever sat on a merry-go-round and suddenly felt कि कोई फोर्स आपको बाहर की तरफ पुश कर रहा है? Or have you seen someone rotating a stone tied to a string? A very interesting question comes here. अगर बॉडी नेचुरली स्ट्रेट लाइन में मूव करना चाहती है, then why does it keep moving in a circle? Who keeps changing its direction continuously? Today we will understand one of the most interesting concepts of physics: uniform circular motion, centripetal force, and the mystery behind centrifugal force. First, let's understand what exactly is uniform circular motion. When a particle moves with a constant speed in a circular path, its motion is called uniform circular motion. So, constant speed and circular path. Simple. Now imagine a cyclist moving around a circular track. Suppose he covers equal distances along the circular path in equal intervals of time. That means his speed is uniform. But now comes the important question. Is velocity also constant? No. And this is the most important point students should understand. Velocity depends on two things: magnitude and direction. In circular motion, speed remains same, but direction changes continuously at every point. And the moment direction changes, velocity changes. And whenever velocity changes, acceleration exists. So even though the speed is constant, uniform circular motion is an accelerated motion. ये थोड़ा strange लगता है initially because generally we think acceleration means increase in speed. But physics says even change in direction of velocity means acceleration. Now another very important question: what is the direction of velocity at any instant? The answer is the direction of velocity at any instant is along the tangent drawn at that point of the circular path. Now imagine a stone tied to a string moving in a circle. Suddenly the string breaks. What will happen? Will the stone move towards the center? No. Will it continue moving in the circle? Again, no. It immediately flies away along the tangent. Why? Because velocity at every instant acts along the tangent to the circle. Now let's compare uniform linear motion and uniform circular motion. Suppose a car moves on a straight road with constant speed. Then speed is constant. Direction is also constant. Therefore, velocity remains constant and acceleration is zero. So, uniform linear motion is an unaccelerated motion. Now imagine the same car moving on a circular track. Here, speed may remain constant, but direction changes continuously. So, velocity changes continuously. Hence, acceleration exists. Therefore, uniform circular motion is an accelerated motion. Now comes the real mystery. A body naturally wants to move in a straight line. Then why does it move in a circle? There must be some force continuously changing its direction. And that force is called centripetal force. The word centripetal comes from two words: centri meaning center and petal meaning seeking. So centripetal force means a force directed towards the center. Centripetal force is the force which acts on a body moving in a circular path in a direction towards the center of the circular path. Without this force, circular motion is impossible. Because without inward force, the body would simply move away tangentially. Imagine a boy standing in a playground. He ties a stone at the end of a string and starts rotating it in a circular path. Now carefully think, at every instant the stone wants to move in a straight line, but the string continuously pulls it inward. That inward pull changes the direction of velocity again and again. And because velocity changes continuously, the stone keeps moving in a circle. So here, tension in the string provides the centripetal force. Now suppose suddenly the string breaks. Immediately, the stone flies away tangentially. Why? Because the centripetal force suddenly disappears. Different types of forces can act as centripetal force. Planet around the sun. Planets move around the sun in elliptical paths. What provides the centripetal force? Gravitational force of attraction by the sun. Moon around the earth. The moon revolves around the earth. Again, Earth's gravitational attraction provides the required centripetal force. Electron around nucleus. In an atom, electrons move around the nucleus. The negatively charged electron is attracted by the positively charged nucleus. So, electrostatic force provides the centripetal force. Stone tied to a string. Tension in the string provides the centripetal force. Now comes a force that confuses almost every student. Centrifugal force. And to understand this properly, let's enter a fun story. Imagine a merry-go-round in a park. A ball is tied to one end of a string. The other end of the string is tied to the center of the merry-go-round. Now there are two observers. Observer 1 standing outside the platform and observer 2 standing on the rotating platform. Both observe the same ball, but surprisingly, both explain the motion differently. Outside observer. The observer standing outside sees the ball moving in a circular path. He says the string tension continuously pulls the ball towards the center. So according to him, tension provides the centripetal force, and that alone explains the circular motion. Simple. But now think about the observer standing on the merry-go-round. To him, the ball appears stationary relative to him. Now he thinks, if the ball is stationary, then forces must be balanced. But he already knows string tension acts inward. So what balances it? To explain this, he assumes another force acting outward. And that imaginary outward force is called centrifugal force. Centrifugal force is the force which is assumed by an observer moving with the body to act on the body in a direction away from the center of the circular path. It acts outward, and for the rotating observer, it appears equal and opposite to centripetal force. Now many students ask, is centrifugal force the reaction force of centripetal force? The answer is no, because according to Newton's third law, action and reaction always act on different bodies. But here, both centripetal and centrifugal force act on the same body. So centrifugal force is not the reaction force. So finally, remember this clearly. Centripetal force is a real force. Examples: tension, gravity, electrostatic force. But centrifugal force is not a real force. It is a fictitious or pseudo force. It is only assumed by an observer moving along with the body in the circular path. So the only real force responsible for circular motion is centripetal force. So next time you sit on a merry-go-round and feel pushed outward, remember, physics is secretly working there. And the reason circular motion exists is because some force continuously pulls the body towards the center. That force is centripetal force. See you in the next physics story.